Okay, we are going to start looking at linear equations and functions. First, we're going to talk about a relation, and when is a relation a function and when is a relation not a function. A relation is a mapping or pairing of input values with output values, basically a pairing of x's and y's. The domain is the set of input values, the x values. The range is the set of output values, the y values. So when you talk about x values, there's really three names: x values, input values, domain. When you talk about y values, there's three names: y values, output values, range. A function is a specific type of relation where there's exactly one output value for each input value. That means only one y for each x. The wording of this can be confusing, and I struggled with this when I was in high school, so that's actually good for you because I can explain it in a way that will hopefully make more sense. Have you seen these mapping diagrams before? Where you've got some numbers here, like -2, -1, 0, and some numbers over here, 5, 6, 7, 8. And then there's arrows connecting them. Have you seen that before? Okay. So let's say -2 maps to 5. -2 also maps to 6. -1 maps to 7. And 0 maps to 8. This is a fancy way of showing how the input and output values are related. Another way to show how these values are related is to write them as ordered pairs. So this relation can also be represented by these ordered pairs: -2, 5, -2, 6, -1, 7, and 0, 8. Okay. This is a relation. It's a listing of inputs and outputs, and the inputs and outputs are related to each other in some way. -2 maps to 5, -2 maps to 6, and so on and so on. Is this a function? In order for this relation to be a function, there can only be one y value for each x value. So, I'm going to grab my highlighter. Take a look here. -2 has the y value of 5. -2 also has a y value of 6. So there are two y values for that one x value. But in order for it to be a function, you can only have one y value for each x value. So this one is not a function. And you may want to write up here next to your definition of function, no repeated x values. That's the phrase that helps me more. You can't have a repeated x value. If you see an x value mapping to two different y values, if you write that out as an ordered pair, you've got that -2 happening twice. You can't have a repeated x value. All right, here's another relation. Let's just use... If you're writing these mapping diagrams and you run out of space in the little box, that's okay. Just keep going beyond it. And I'm going to do -1, -2, -3. All right. -2 maps to -1. -3 maps to -2. +4 maps to -2. And 5 maps to -3. We need to decide, is this relation a function? The 2 only has one y value. The 3 only has one y value. The 4 only has one y value. and the 5 only has one y value. So is it a function? Yes. Now what does this mean? Repeated y values are okay. Now, what we were actually supposed to do with this example is identify the domain and range, then tell whether the relation is a function. So we decided that yes, this is a function. For the domain, all you need to do for the domain is list the x values in numerical order and don't write any repeats. So if 2 is on there twice, don't write 2 twice. For the range, all you need to do is write the output values in numerical order. So since I did not write them in the table in numerical order, we should write them in our range in numerical order. So yes, it is a function, and there is the domain and the range. Where it says ordered pairs down below, this is actually kind of a segue into the vertical line test. And I want to make sure that you know how to plot points. So we already did this up above. We can represent a relation using a list of ordered pairs, just like we did right up here. The x-coordinate is the first number in the ordered pair. The y-coordinate is the second number in the ordered pair. So I'm going to do a pretty simple relation. 1, 5, 3, -2, and 5, 1. Let's plot these 3 points and see how they look on the graph. On this graph, technically there's no x or y axis shown. I like to use these graphs because you can make the x-axis here and y-axis here. So you can put your origin here or anywhere based on the numbers that you need to put on your graph. So technically you should trace in your x-axis and label that as your x-axis, and trace in your vertical. This is me angry. Trace in your vertical axis and label that as your y-axis. Do not push the button on my stylus. Okay, plot those 3 points. Remember, the first number is your x value and the second number is your y value. So the point 1, 5, you'd go 1 to the right on the x-axis and then up 5 on the y-axis, and that's the location of the point. Is this relation a function? Yes. So I'm going to write, this is a function. Now, if we add 3, -3, would it still be a function? Why not? Very good. Why did you just zoom in like that? Silly crap. Okay, so if I take this point 3, -3, and plot that in there, I used green to plot it, now this is not a function. And this leads us into the vertical line test. Do you see how those 2 points line up vertically? If you were to draw a vertical line, several vertical lines through this relation, you'd notice that when you hit that spot, a vertical line would hit more than 1 point. That means it's not a function. What the vertical line is doing is it's checking to see, are there any repeated x values? If there's more than one x value of 3, those points are going to line up vertically. So go to page 2, and I want you to try using the vertical line test to determine if those relations are functions or not. What the vertical line test means is if you put a whole bunch of vertical lines through each of these graphs, each vertical line can only touch 1 point. If a vertical line touches 2 points on the graph at the same time, it is not a function. Now, you don't have to physically draw in vertical lines. You can take your pencil vertically and run it along the graph, and if you ever see 2 points touching your pencil at the same time, it's not a function. Okay, the next example, it says graph the relation, then tell whether the relation is a function. So take a moment, plot these points, and then decide, is it a function, yes or no? Because there are no repeated x values and the vertical line test does not go through 2 points at one time, this is a function. All right, I know that several of you know how to graph equations without using a table of values, but we are going to start by using a table of values. So let's graph this. Start by constructing a table of values with x's and y's. We need to pick 3 x values. I suggest picking something negative, 0, and something positive. It doesn't matter what numbers you can pick anything. I like to look at the equation we're working with, like say that was 1/2 x instead of 2x. Is it easy or difficult to do half of an odd number? More difficult than doing half of an even number. So based on what equation you're plugging into, think about what x values would be easy to plug in and pick those. For this one, I'm going to do -2, 0, and 2. Plug whatever numbers you chose into this function. So 2 times -2 is -4, and -4 plus 1 is -3. Plug the other numbers in, plot your points, and then draw a straight line through those points. Okay, I will try to draw as straight of a line as possible given the restrictions of this computer. But for you, you should be able to draw a perfectly straight line. Once Wildcat Hour begins, you all should have your ID on you because you have to wear it during Wildcat Hour. Your ID is inside, I believe, a little plastic holder that has a nice straight edge on one side that's approximately the same width as one of these graphs. So if you have your ID on you, which you should, put that against these 3 points and draw in a nice straight line. You all have a wonderful straight edge that you should have with you at all times. I will simply do my best. Okay, the next one, y equals -x. This one's a little bit weird. I'm still going to choose -2, 0, and 2. I feel like those are some good points to try. If I plug in -2, what is -2? 2. If I plug in 0, what is -0? And what is -2? -2. Plot those points. Okay, how are you doing on the graph so far? Good. Turn to the next page. Oops. The next one, y equals 2. Again, I'm going to make a table of values using a negative number, 0, and a positive number. What do you notice about this equation, though? There's no x. So if I, quote, plug in -2, what is y going to equal? 2. If I plug in 0, what is y going to equal? 2 and 2. Y is always going to equal 2. Because there's no x, there's no place for you to plug these numbers in. It doesn't matter what these are, y will always equal 2. Let's plot that. And I'm going to be lazy and maybe not have those in there. Okay, -2, 2, 0, 2, 2, 2. What kind of line is created? A straight horizontal line. If you have y equals a number with no x, it is a horizontal line. If you have x equals a number with no y, what do you suppose it's going to be? A vertical line.